Same thing, Josh. Best if you talk and I look for flaws.
So we know it's f double prime. We're looking for f. Point of inflection could be like when it's, is that when it's changes increasing to decreasing? No, is that?
No. Keep going. You were gonna say it, I know.
0 then? No, that's the critical point.
So here's what you have to have memorized on a flashcard if you're struggling. F has an inflection point when F changes concavity. So that's where you have to start the problem.
Okay.
Then you have to say, great, they want me to find when F changes concavity, but I'm not looking at F. So I have to figure out how is F double prime going to change when F is changing concavity. So do you know how to do that? Like how to figure out, like somebody helping. How can you figure out, how is F double prime going to be changing when F is changing concavity? How do I remember? Go.
Oh, you should go straight to Danica's chart and look when f double prime is positive or negative to see when f is concave up or concave down.
It's perfect. So the whole key to the problem is, one, having memorized this, there's nothing else you can do but memorize it. It's just the definition. Then pay homage to Danica Wright and thank her for her chart. And then remember that when f double prime is changing from positive to negative, that won't be f double prime changing concavity, but it will be f changing concavity. So I'm going to trace this graph, Josh. You say stop when you think we hit an important point on this graph of f double prime. Actually, you can just tell me, like at what letters? There's A, J, O, K, M, and B. Which of those letters is are the important points?
O is on.
Yes, because at O, f double prime is changing from negative y values to positive y values. That means f will be changing concave down to concave up. Where else?
Is this where we go like in between where the lines would be? So like in between like the local max and min, is that kind of one of the values we turn from? No. Like would M be one?
What you're mixing up there is you're mixing up a point of inflection for f double prime with a point of inflection for f.
Okay.
So M is likely a point of inflection for f double prime because f double prime is concave down. Now f double prime is concave up.
Okay, so A is one.
Yes. So A is the spot where f double prime is changing from positive y values to negative y values. That's another place where f will change concavity.
Okay.
Concave up to concave down. Please.
So this was not a double prime graph, but just an F graph where we count the concave up and concave down.
Yes, perfect. So what Cami just said was, hey, what if they give me a different question and they say this is f double prime, identify where f double prime has inflection points. Your thinking is totally different. You're thinking, okay, I'm just looking at f double prime, and you'd be thinking f double prime changes concavity. Let's see, f double prime is concave up, right about here. F double prime becomes concave down. Now f double prime switches back to concave up.
So if it was an F graph and it never actually went to the negative values, or kind of went below the x-axis, but it still had concaves, that would.
Let me say it back to you, Cami, make sure I'm answering your question. So you're saying, what if I have a graph of f that looks something like this, perhaps? that your question? This graph of F definitely changes concavity about right there.
If it was a double prime graph, it wouldn't have inflection point.
I have to say that a little more carefully. If this were F double prime would still have an inflection point here. But if you're looking at F double prime and trying to figure out if F has an inflection point, the answer would be no, F does not have an inflection point. Because F double prime is never changing positive to negative. So when you look at Danica's chart, think of it this way. Welcome, Chase. One second. Danica's chart goes on forever. It never stops. So look, on lots of these problems, what you have to do is it's like you have to put in one hand, what am I looking at? And you have to put in the other hand, what am I trying to find? So you've asked several really good questions. One question is, what if I'm looking at F double prime right here, and I'm also trying to figure out something about F double prime? So I'm looking at F double prime, trying to find the inflection point on F double prime. In that case, my eye is only looking right here and nowhere else. I'm just looking to see where does F double prime change concave up to concave down or vice versa. That's all I'm looking at. So if this is an F double prime graph and I'm looking for the inflection point on F double prime, I found it. However, what I'm looking at is F double prime, but I'm trying to see where F has an inflection point. Now I've got to look in two places. I have to say F has an inflection point when this happens, right here. And, okay, great. It's going to bother me forever. Sorry. So I'm looking here. That's what I want, but I can't see this because I'm not looking at the graph of F. So I have to look at my other hand and say, oh, I really need to observe this. And on this particular example, this never happens. F double prime has all positive y values. So my unseen graph of F won't change concavity. Does that answer your question? Follow up on this one. John?
So then if you were like looking at like say an F prime graph and you were trying to find out something about F, the point of inflection would be when the tangent slope is 0. Because it goes from increasing to decreasing or vice versa.
Gotta pause and think for a second. The tangent slope wouldn't necessarily have to go to 0. But F prime will have to change from increase to decrease.
Oh, because it might be like a...
Right, it could be a corner. Does that make sense?
Yeah.
So, does that answer your question? Perfect. Okay, I apologize, I gotta go to the office. Like, that's why I sent a text, stop at 7:30. If I try to go too much further, I can't get class started on time, so sorry that I can't. I don't know why I'm apologizing after 6:30. Is it all right? Yeah.
Can you run these through?
Yes, if you bring it to me, I can do that real fast. Then Rachel, you have the key still.
Oh, yeah.
No worries. No problem. I can run as fast as it's quicker than this. There you go. Not bad. Not bad. I wrote
X squared minus A squared.
7 zigzag.
Wait, zero meaning,
Zigzag.
you said 7 meaning